Alright, welcome to yet another test review. Today you will be learning about the brand new ways to do logarithms. Anyways, just kidding. So make sure again, guys, you would need these three properties are very important for understanding what we're going to be doing with the logarithms, because you want to make sure that you're using those properties. And a lot of this is about showing me that you have knowledge of the properties, not that you're just a mindless little drone that can say type into a calculator. Alright, so shall we begin? So on problems number 1, 2, and 3, you have to show me the properties. I will give you a log value. Like in this case, log base 10 of 4 is approximately 0.6021, and log base 10/9 is 0.9542. Okay, and when I give you something like log 10 4/9, I don't want you to just type it in the calculator. You have to show me that it's like, okay, 4/9 means I can go here and I can say, according to this, that I can go here and say, oh, use the second property. Dividing means I can separate them by subtraction and go log 4 minus log 9, in base 10, of course, is equal to 0.6021 minus 0.9542 to get negative 3521. Now, if I give you a number, I don't care what that number is. Realize that it is in terms of whatever two numbers I gave you in the direction. So in this case, 4 and 9. And that's the only numbers that should be able to say divide into it. Even if there are other numbers that you know of that can divide into it. So like in 144, I would have divided it by 4, got 36. 36 I can divide by 4 to get 4 and 9. So I only want this in terms of 4 and 9, which is what I have it now. I have no clue why I rewrote that. And so I could say that's log 4. I'm going to skip through the next part. Let's get through there. Times 4 times 4 times 9. And thus I could say that's, well, plus, because times means I can add. So separate them into 3 separate logs and add. And then just substitute in, add them up, and get an answer. Easy peasy, right? Yeah, I got it. Okay. Alright, so let's look at number 3. Number 3 is same thing. Okay, to get the 2.25, if you want to convert that to a fraction, you would have to say do menu 22. So you'd type in the net 2.25, then hit menu 22, press enter, and it would tell you that 2.25 is 9/4. What? Yeah. So anyways, 9/4, then go from there, da-da-da. So I'm saying log 9 minus log 4, and then substitute in, subtract, and get my answer. Again, none of this should be difficult. You just got to show me the properties. Okay, so now let's look at number 4. The number 4. Okay, so again, I can't just get rid of the logs because there's a log on one side and a log on the other side. There is a 5/2 multiplying that. So I have to somehow move or change the 5/2. And according to property 3, which we'll go back over here, what went too far. Property 3, if I have a number in front, I can move it to become the exponent of inside the log. So I'm over here, there we go. I can move that 5/2 to be part of the 25 and say log 25 to the 5/2 power. Now, whoops, went too far. Now I've got, say, where I can get rid of the logs. Okay, let's see if I don't have stubby fingers now. I can get rid of the logs and say n equals 25 to the 5/2 power, which would be 3125. On number 5, I can combine the two logs because of the plus. That property number 1 allows me to combine the two, just like I could separate them and say a times is like a plus. I can combine them and say a plus tells me I can multiply the two together. So 7n times 4 is 28n. And then I can drop the two logs and say 28n equals 168 and divide by 28 to get n equals 6. Oh, that seems easy. I'm glad y'all think that. Alright, number 6 and number 7 is just a matter of rewriting. You're just like one is in logarithmic form, you're rewriting into exponential form. Another one's in exponential form, you're rewriting into log form. Not much more I can say about that. Other than, it should be easy. Let's see here. Now, number 8, we got to use the properties. You know, all these properties and saying like I got to move something to an exponent and say something is the power of something else, maybe that should be your secret word for today. So today, or for the test, your secret word will be power. You've got to write the word power onto the thingamabobby. Okie dokie, got to write it on your test, when tomorrow when you take the test. Anyways, I got to move the 2 and the 3 to become exponents of the 8 and the 4. My goal is to make sure you write these as single logarithms. So notice that I'm making the numbers in front become the exponents, and then a minus means divide. I am happy with the answer just like that. Now again, you might want to go a little further because you're just kind of silly that way, and say 8 squared is 64, 4 cubed is 64, and then 64 divided by 64 is 1. But again, whoops, I am happy with it just like that. Okay, number 9, good grief, that was kind of crazy. Number 9, the same thing. I'm going to move the 5 and the 2 to become exponents, and then I'm going to join them by multiplication. And I'm happy with it right there, like that. But if you want to tell me 3 to the 5th is 243, hey, more power to you. Way to go. You got it, buddy. All right. Now, so how do we go? And that's pretty much it. That's all you're doing is, again, showing me how to use the properties. The properties. Okay, number 10 and number 11. The idea here is to get e by itself. So in the first one, I'm going to add and then divide. And then once I got e by itself, I can take the natural log to get rid of the e, the ln. And then that would tell me that x equals whatever ln of 5 is. On number 11, I need to divide by 3 to get e to the 4x equals 20 to equals 8. And then again, e's by itself, so I can take the ln to get rid of the e. That gives me 4x equals whatever ln of 8 is. Then divide by 4 to get 0.52. 0.52. And there you go. On number 12 and 13, all you're doing is using the e to get rid of the ln. And then you just got to add, subtract, or divide, depending on what I ask you to do. In number 12, you got to subtract. And then on number 13, you got to divide. You got to divide. You got to divide. Anyways, so there you go. And those should be pretty easy. Now, again, if you don't quite fully understand, I should be at the school before at the beginning of the day, like at 7:30, so I can answer any questions you may have before you would take the test. Anyways, all right. So for the blah 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 blah. Let's try that again. For the word problems, these are the main properties you would be using. Nothing very difficult. A to the bx, a times 1 plus r to the t, a times 1 minus r to the t. Those are the decimal ones. A e to the kt, a e to negative kt. Now, usually the last two, I would probably give you the k or the t and tell you to find, one or the other. But you'll see. Anyways, on number 14 is kind of funky because actually that one is where I could have actually divided that up into two problems. It says that substance has a half-life of 3 hours. Find out how much substance will be left in the 500 milliliter sample after 8 hours. First thing you got to do is find the k. So this is one where I could have said, oh, find the k. And then say half-life, you always say half of a equals a. And then the a's cancel out, leaving you ln equals 1/2. Ln of 1/2 equals ln of e, and those would cancel out, leaving me negative 3k. By the way, that should have been a negative because I forgot the negative. And then you divide by negative 3 to get that k constant is equal to 0.231. Now, that would have been one question. Another question could have been like what the question actually asked, how much substance will be left in a 500 milliliter sample after 8 hours? But to give you that question, I would have had to have given you that k. So assume that if I could give you it one way or the other, but question 14 is not going to be like this double problem. It's going to be one or the other. And so notice on the second part, all I had to do is put the numbers in, plug it in, type it into the calculator, and press enter, and to get 78.76 milligrams. All right, number 15, because of the percent, that one's telling me the 1 minus r. So I would say a is equal to 1 minus r to the t power. A is the 19,000, the initial amount of the truck. The r is the 12%, which is changed to a 0.12. And the t is 3 years, and then just plug it in and get your answer. 16 is the same thing, except that it's a plus because it was increasing. And basically I find out, like, I'm just plugging the numbers in. All you got to do there, those should be fairly easy and straightforward. And yes, I will have some where all you got to do is plug in the numbers. Then what about the ones where you have to use logs or natural logs? Well, that would be, say, the last two. So on the last one, number 17, we have an initial population, and because of the percent, I know I have to use the 1 minus r, and it is declining. Anytime you have like something like this, just like you would in E, you first get the number that has the exponent by itself. So I have to get rid of the 589. And by the way, I wrote 589 instead of 589,000 to show that it was in thousands. Because those zeros are just extraneous. You'll divide them out anyway. And then from there, I can take the log. Once I get down to this point where I have just some number with the t, I can take the log of both sides. That could be ln or it could be log. It doesn't really matter. And then that would give me two separate numbers, and then I would have to divide t by those to get that answer. Or divide the number that's next to the t by that. And that would give me the answer that would tell me that's about 0.999 something years, or 9.994 years. More likely what I would do is something closer to 18, where I give you, like, say, populations, two different populations, and I say find the k. And you can tell that it was 12 years, because from 2000 to 2012 is 12 years. You divide, you take the ln to get rid of the e, and then you can divide by 12 to get your final answer. But again, these are things that we should be able to do. Keep in mind, I do want to see the setups. So I do want to see these setups first before you say try to start trying to solve. Because if you try not to solve, if you don't solve, or if you don't show me that you're going to solve, or you just give me an answer but you don't show me how or give me the setups, I'm not going to give you credit. So again, a lot of this is about showing me that work. Anyways, that's it for today, kiddos. Y'all take care. Thank you so much.